30 plus, hey there, welcome. Do you want to pass the CKAD exam in 2026? I know, looking at all those new Kubernetes updates can feel scary. But don't worry. You are in the right place. We are going to break this down, piece by piece, so you feel ready and confident. Stick with me, and let's get you certified. This is part of the complete course. You can get the link in the description for complete practice questions with explanations which will help you get your certification. Before we start, just know that this is a sample to get you going. If you like what you see here, check the description below. I have a full set of practice tests on Udemy, and some really cool visual study guides on Etsy. Those resources are there to give you that extra push if you need it. How to learn quickly. So, how do you learn this stuff fast? Here is the secret. Don't just read. You have to do the work. Open your terminal and type the commands with me. When you make a mistake, that is actually good. That is when you learn the most. Take your time, breathe, and let's focus on understanding the core concepts. Section 1. Application Design and Build Details, Concept Overview. Let's start with the basics, because a strong foundation is what you need. In this section, we look at how you build the apps that run on Kubernetes. First, think about container images. Everything starts here. You need to know how to define a build using a Dockerfile. You should know commands like from, run, and cmd. The exam might ask you to fix a broken file, or create a new one. Remember, the image is just a package of your software. Next, we talk about jobs and cron jobs. A normal pod runs forever, like a web server. But sometimes, you just want to do one thing and stop. That is a job. Maybe you need to calculate a report, or clean up a database. Once the work is done, the job finishes. If you need to do that work every night at midnight, you use a cron job. It is just like a job, but with a schedule attached to it. Then, we have multi-container pods. Usually, we put one container in one pod. But sometimes, you need a helper. Imagine you have a main app, and it generates log files. Container in the same pod to pick up those logs and send them somewhere else. This is often called a sidecar pattern. You need to know how to put two containers in one YAML file so they can talk to each other. Also, we need to look at persistent volumes. Containers are temporary. If a container crashes, the data inside it is gone. That is bad for a database. So, we use volumes to save data safely. You create a persistent volume claim, or PVC, to ask Kubernetes for storage. Finally, understand init containers. These are special. They run before your main app starts. You use them to set things up. For example, maybe your app needs a configuration file created before it can turn on. The init container does that work, then it dies, and then your real app starts. Knowing these pieces helps you design apps that are strong and easy to manage. When you look at the questions below, try to picture these concepts in your head. 15 practice questions. Section 1, Question 1. You need to create a Dockerfile. Which instruction do you use to specify the base image for your build? Answer. You use the from instruction. Explanation. Every Dockerfile must start with from 9 or from Alpine. Question 2. you are running a job that computes pi to 2000 places. You want the job to automatically delete itself 100 seconds after it finishes. What setting do you add? Answer: you add TTL seconds after finished, 100 to the job spec. Explanation: this field tells the controller to clean up the job and its pods after the work is done and the time has passed. Question 3. You need to run a task every day at 2 a.m. What kind of Kubernetes object should you create? Answer: you should create a cron job. Explanation: a cron job creates jobs on a time schedule. You use the standard cron syntax to define the time. Question 4. In a multi-container pod, how do the containers communicate with each other using the network? Answer: they talk to each other using localhost. Explanation: containers in the same pod share the same network namespace. They can reach each other on different ports using the localhost address. Question 5. You have a main container that serves a website. You need a second container to watch the logs and send them to a server. What is this design pattern called? Answer: this is called the sidecar pattern. Explanation: the sidecar sits next to the main container to help it, usually for logging, monitoring, or syncing files. Question 6. You want a script to run exactly once before your main application container starts. Where do you define this container in the YAML? Answer: you define it under the init containers section. Explanation: init containers must complete successfully before the regular containers in the pod begin to start. Question 7. You are writing a Dockerfile. Py from your computer into the containers src folder. What command do you use? Py src. Explanation: the copy instruction takes files from your local host and puts them inside the image file system. Question 8. Your job keeps failing. You want it to try 4 times and then give up. Which field controls this? Answer: the field is backoff limit. Explanation: backoff limit specifies the number of retries before marking the job as failed. The default is usually 6. Question 9. You need to create a persistent volume claim, PVC, to ask for 1 GI of storage. What access mode allows the volume to be mounted by a single node in read-write mode? Answer: the mode is read-write once. Explanation: read-write once means the volume can be mounted as read-write by a single node. This is common for block storage. Question 10. You are creating a pod. 19. Which command gives you the YAML definition of a running pod named web without deleting it? Answer: use kubectl get pod web OYAML. Explanation: the OYAML flag outputs the complete configuration of the object, allowing you to check the image tag. Question 11. How do you define a command in a Dockerfile that runs when the container starts, but allows the user to override it easily? Answer: you use the CMD instruction. Explanation: CMD provides default arguments. If the user runs docker run image _name command, the CMD is ignored. entrypoint is harder to override. Question 12. You have an init container that creates a file. How can the main container see this file? Answer: they must share a volume. Explanation: you mount the same volume, like an empty dir, into both the init container and the main container so they can access the same files. Question 13. What happens to a cron job if the previous job is still running when the next scheduled time arrives? Answer: it depends on the concurrency policy. Explanation: if set to allow, a new job starts. If set to forbid, the new run is skipped. If set to replace, the old one is stopped and the new one starts. Question 14. You need to build a container image inside a Kubernetes cluster without using Docker locally. What tool is commonly to override the container's default command? Answer: you use the command field in the pod spec. Explanation: the command field in Kubernetes overrides the entrypoint of the Docker image. The args field in Kubernetes overrides the CMD. Section 2. Application Deployment Details, Concept Overview. Alright, let's move on to Section 2. Now that you have built your app, you need to run it. But you don't just want to run one copy. You want to run many copies, and you want to update them without breaking anything. This is where deployments come in. Think of a deployment as a manager. The manager creates 3 pods. If one pod crashes or gets deleted, the deployment notices. It immediately starts a new one to replace it. It keeps your app alive. This is the main way you will run apps in the real world. Now, what happens when you change your code? 0. You don't want to stop the whole system to upgrade it. That would make users angry. Instead, we use rolling updates. This is the default way Kubernetes updates things. It takes down one old pod and starts one new pod. Then it does the next one. This way, your app stays online the whole time. You need to know how to control how fast this happens using max surge and max unavailable. Sometimes, you need to go back. 0 has a bug. You can use the rollout undo command. It is like a time machine. It reverts your app to the previous version instantly. This is a lifesaver during the exam and in real jobs. We also need to talk about blue, green and canary deployments. These are fancy words for safe updates. In blue, green, you run the old version, blue, and the new version, green, at the same time. You switch the traffic all at once. In canary, you send just a little bit of traffic to the new version to test it. If it works, you send more. You handle this by playing with services and labels. You change the labels on a service to point to the new pods. Finally, let's touch on Helm. Helm is like an app store for Kubernetes. A chart is a package. You can install a complex database with just one command, Helm install. You need to know how to find charts and how to use them. Understanding these strategies makes you a safe driver. You can move fast, but you won't crash the car. 15 practice questions. Section 2, Question 1. You want to scale your deployment named web app to have 5 replicas. What command do you run? Answer: kubect-l scale deployment web app, replicas equals 5 explanation. This command updates the deployment spec to request 5 running pods. The controller will create new ones to match this number. Question 2. You updated an image and the app is crashing. You need to go back to the previous version immediately. What command do you use? Answer: kubect-l rollout undo deployment less than deployment name greater than explanation. This command reverts the deployment to the previous revision stored in its history. Question 3. You are performing a rolling update. You want to ensure that at least 75% of your desired pods are always up and running during the update. Which field do you set? Answer: you set max unavailable to 25%. Explanation: max unavailable controls how many pods can be down during the update process. 2 with 3 replicas. How do you do this with a single command? 2 replicas equals 3 explanation. The create deployment command generates the deployment resource for you. Question 5. You want to see the history of changes made to your deployment. Which command helps you here? Answer: kubect-l rollout history deployment less than deployment name greater than explanation. This lists the revisions. If you used the record flag, though it is deprecated, you might see the command used for each change. Question 6. In a canary deployment, how do you direct only a small portion of traffic to the new version? Answer: you create a separate deployment for the new version with fewer replicas, but use the same labels as the main deployment. Explanation: the service balances traffic across all pods with the matching label. If you have 9 old pods and 1 new pod, the new one gets 10% of the traffic. Question 7. You are using Helm. You want to see a list of all the charts you have installed in the current namespace. What command do you run? Answer: Helm list explanation. This command shows all releases, which are the installed instances of charts. Type. How do you do this in the command line? Answer: use the set flag. Type equals node port. YAML file. Question 9. What is the difference between a deployment and a stateful set? Answer: a stateful set maintains a unique identity and order for each pod, while deployment pods are interchangeable. Explanation: stateful sets are used for databases where it matters which pod is which, like pod 0, pod 1. Deployments treat all pods as equal. Question 10. Your rolling update is stuck. You want to pause it to investigate. What command do you use? Answer: kubect-l rollout pause deployment less than deployment name greater than explanation. This freezes the update process. No new pods are created, and no old pods are killed until you resume. Question 11. You have a blue-green deployment strategy. How do you switch all traffic from blue to green instantly? Answer: you update the services selector to match the labels of the green deployment. Explanation: the service sends traffic to pods that match its selector. Changing the selector redirects traffic immediately. Question 12. How do you add a repository to Helm so you can install charts from it? Answer: Helm repo add less than repo name greater than less than URL greater than explanation. This tells Helm where to look for the charts. You usually run Helm repo update afterwards. Question 13. You want to see the values that were used to configure a specific Helm release named MyWeb. What command allows this? Answer: Helm get values MyWeb explanation. This retrieves the user-supplied values for that release. Question 14. A deployment is failing to pull the image. You see image pull back off. Where should you look for the detailed error message? Answer: run kubect-l describe pod less than pod name greater than and look at the events section. Explanation: The events section at the bottom of the output explains why the scheduler or kubelet failed to start the container. 20. Without editing the YAML file manually. What command works? 20. Explanation. This imperative command updates the image field and triggers a rollout automatically. Section 3. Application Observability and Maintenance Details, Concept Overview. Now we are on Section 3. This part is about keeping your eyes open. Once your app is running, how do you know it is healthy? How do you fix it if it breaks? This is called observability. First, we use probes. Kubernetes needs to know if your app is working. If the answer is no, Kubernetes kills the container and starts a new one. Maybe your app needs 10 seconds to load a database connection. If the answer is no, Kubernetes stops sending users to that pod until it is ready. This stops users from seeing errors. There is also a startup probe for slow starting apps. Next, let's talk about logging. When something goes wrong, you need clues. In Kubernetes, you use kubectl logs to read them. It is simple but powerful. You have a pod with 2 containers. You must tell Kubernetes which container you want to read logs from. Then we have monitoring. This is about metrics. How much CPU is your app using? How much memory? If your app uses too much, it might get killed. Killed. The metrics server collects this data. You can see it using kubectl top. This helps you decide if you need to give your app more resources. Finally, debugging. Sometimes you just need to get inside the container to see what is happening. You can use kubectl exec to run a shell inside the pod. It is like sshing into a server. You can look at files, check network connections, and test things from the inside. This section is very practical. In the exam, something will be broken, and you will use these tools to find out why. 15 practice questions. Section 3, Question 1. Your application crashes immediately after starting. You suspect a configuration error. Which command lets you check the application logs? Answer. Kubectl logs less than pod name greater than explanation. This prints the standard output, stdout, and standard error, stderr, from the container. Question 2. You have a pod named web with 2 containers, main app and sidecar. How do you view the logs of the sidecar container? Answer. Kubectl logs web c sidecar explanation. When a pod has multiple containers, you must specify which one you want using the C flag. Question 3. You want to configure a pod so that it restarts if the application freezes and stops responding. Which probe do you use? Answer. A liveness probe. Explanation. The liveness probe checks if the app is running. If the probe fails, the kubelet kills the container and restarts it. Question 4. Your app takes 30 seconds to warm up and connect to the database. You want to ensure no traffic is sent to it during this time. Which probe do you use? Answer. A readiness probe. Explanation. The readiness probe checks if the app is ready to serve requests. If it fails, the pod is removed from the service load balancer. Question 5. You want to see how much CPU and memory your pods are currently using. What command provides this live data? Answer. Kubectl top pod explanation. This command queries the metrics server to show current resource usage. Question 6. You need to run a command inside a running container to check a config file. The pod name is my pod. How do you get a shell access? Answer: kubectl exec id my pod, bin, shush, or bin, bash. Explanation: exec runs a command inside the container. It makes it interactive so you can type in the shell. Question 7. A pod is constantly restarting. The status says killed. What does this mean? The container tried to use more memory than its limit allowed. Explanation: you likely need to increase the memory limit in the pod resources or fix a memory leak in the code. Question 8. Where do you define probes in the YAML configuration? Answer: inside the containers section of the pod spec. Explanation: probes are defined per container, not per pod. Question 9. You want to check the events for a specific namespace to see if there are any errors like scheduling failures. What command helps? Answer: kubectl get events n less than namespace greater than explanation. This lists recent events in that namespace, sorted by time. Question 10. Your liveness probe is failing because it checks port 80, but your app is listening on port 8080. How do you fix it? Answer: edit the pod YAML and change the port field in the liveness probe section to 8080. Explanation: the probe must match the actual port the application is using. Question 11. You have a legacy application that takes 2 minutes to start. The liveness probe keeps killing it before it can finish starting. What should you add? Answer: a startup probe. Explanation: the startup probe disables the liveness and readiness checks until the app has successfully started up once. Question 12. You are trying to debug a service connection. You want to see if a pod can reach a specific IP address. How can you test this? Answer: exec into the pod and use curl or wget to the IP address. Explanation: kubectl exec id less than pod greater than, curl less than IP greater than allows you to test network connectivity from the perspective of the pod. Question 13. Which probe supports checking an HTTP endpoint, a TCP socket, or running a command? Answer: all 3 types, liveness, readiness, and startup, support these mechanisms. Explanation: you can check a URL, HTTP GET, a port connection, TCP socket, or run a script, exec. Question 14. You want to see the definitions of all the API resources available on the cluster to understand short names, like PO for pods. What command do you run? Answer: kubectl API resources explanation. This lists all available resource types, their short names, and API groups. Question 15. If a readiness probe fails after the pod has been running successfully for an hour, what happens? Answer: traffic stops going to that pod, but the pod is not restarted. Explanation: readiness failures only remove the pod from service endpoints. The pod continues running to try and recover. Liveness failures cause restarts. Details, concept overview. Welcome back. We are now on section 4. This part is all about how you configure your applications. You never want to put passwords or settings directly inside your code. That is unsafe. Instead, we use ConfigMaps and secrets. Think of a config map like a list of settings. You create the map, and then you give it to your pod. The pod can read it as an environment variable, or as a file on the disk. Then we have secrets. These are just like ConfigMaps, but for sensitive stuff. Passwords, API keys, and certificates go here. Kubernetes encodes them so they are not easily readable. You use them the exact same way as ConfigMaps. We also need to talk about service accounts. Every pod has an ID card. By default, it uses the default ID. But sometimes, your app needs to talk to the Kubernetes API to get information about other pods. For this, you create a special service account. You give it permissions, and then you attach it to your pod. Finally, let's look at resource requirements. You need to tell Kubernetes how much CPU and memory your app needs. A request is what your app needs to start. A limit is the maximum it is allowed to use. If you don't set these, one bad app can eat up all the memory on the server and crash everything else. This section is very common in the exam. You will definitely have to create a secret or a config map. 15 practice questions, Section 4, Question 1. You need to create a config map named app-config with a key DB host set to localhost. What is the command? Answer: kubect-l create config map app-config, from literal equals DB host equals localhost explanation. The from literal flag allows you to create key value pairs directly from the command line without a file. Question 2. You have a secret named mySecret. You want to use it as an environment variable in your pod. Which field in the pod YAML do you use? Answer: env from or value from under the env section. Explanation: value from selects a specific key. Env from loads all keys in the secret as environment variables. Question 3. You want to update a config map that is mounted as a volume in a running pod. Do you need to restart the pod to see the changes? Answer: no, you do not. Explanation: config maps mounted as volumes update automatically, though it might take a minute or two. Environment variables, however, do require a restart. Text. What command do you use? Text, and the value is the file's content. Question 5. What happens if a container tries to use more memory than its specified limit? Answer: the container is killed, killed, and restarts. Explanation: memory is a non-compressible resource. If you hit the limit, the kernel stops the process to save the system. Question 6. You want to ensure a pod is only scheduled on a node that has at least one CPU core available. Which field do you set? CPU field to 1. Explanation: the scheduler uses requests to find a node with enough space. Limits are ignored during scheduling. Question 7. You need to run a pod with a specific service account named build robot. Which field in the pod spec do you use? Answer: service account name, build robot explanation. This field assigns the specific identity to the pod. If you leave it empty, it uses the default account. Question 8. How do you decode a value from a secret to see what it really says? Answer: echo, encoded _value, base 64, decode explanation. Secrets are stored as base 64 encoded strings. You need to reverse this to read them. Question 9. You want to create a pod that consumes a ConfigMap key special underscore level and sets it as an environment variable named level. How do you write this in YAML? Answer. Use env, then name, level, then value from, then ConfigMap key ref. Explanation. ConfigMap key ref points to the specific config map and the key inside it. Question 10. You are creating a service account. You also want to create a role binding to give it permissions. Can you do this in one command? Answer. No, these are separate objects. Explanation. You must create the service account first, then create the role binding that links the account to a role. Question 11. What is the default service account name if none is specified? Answer. Default explanation. Every namespace has a default service account that is automatically mounted into pods. Question 12. You want to delete a config map named old config. What is the command? Answer. kubect l delete config map old config explanation. This removes the object. Any pods relying on it might break if they restart. Question 13. Why should you set a CPU limit? Answer. To prevent a container from using all the CPU on the node and slowing down other containers. Explanation. CPU limits throttle the container. It won't be killed, but it will run slower if it tries to exceed the limit. Properties. You want to create a config map where the key is settings and the value is the content of that file. What flag do you use? Properties explanation. You can rename the key by putting the desired key name before the equal sign. Question 15. Can a pod use a secret from a different namespace? Answer. No, it cannot. Explanation. Secrets and config maps are namespaced objects. Pods can only mount them if they are in the same namespace. Section 5. Services and networking details, concept overview. Section 5 is exciting. Your app is built, configured, and running. But right now, nobody can talk to it. It is isolated. We need to fix that using services and Ingress. A service gives your pods a stable IP address. Even if the pods die and come back with new IPs, the service IP stays the same. There are a few types. 1. Cluster IP. This is the default. It only works inside the cluster. Good for databases. 2. Node port. This opens a port on every server, node, in your cluster. You can access your app using the node's IP and that port. 3. Load balancer. This asks your cloud provider, like AWS or Google, to give you a real public IP address. Then we have Ingress. Think of Ingress as a smart receptionist. You have one IP address for your whole cluster. blog. Based on that, it sends the user to the correct service. It saves you money because you only need one load balancer. Finally, we have network policies. By default, all pods can talk to all other pods. This is not always safe. You might want to stop the front end from talking directly to the database. A network policy acts like a firewall rule. Understanding networking is key to making your app reachable and secure. 15 practice questions. Section 5, Question 1. You want to expose a deployment named MyWeb inside the cluster only. Which command creates a service for this? Port equals 80, target port equals 8080, type equals cluster IP explanation. Cluster IP is the default type, keeping the service internal. Question 2. You created a service, but it cannot find any pods. The endpoints list is empty. What is the most likely problem? Answer: the service selector does not match the pod's labels. Explanation: the selector must match the labels exactly. If there is a typo, the link is broken. Question 3. You need to allow traffic on port 80 into your pods from any source. What kind of object do you create? Answer: a network policy. 0/0 or empty selector. Question 4. What is the range of valid ports for a node port service by default? Answer: 3000-32767. Explanation: Kubernetes reserves this high port range for node port services to avoid conflicts with standard ports. Org to service B. What resource do you use? Answer: an Ingress resource. Explanation: Ingress rules allow you to define host-based routing. Question 6. You want to see all the network policies in the dev namespace. What command do you run? Answer: kubectl get netpol ndev explanation. Netpol is the short name for network policy. Question 7. Which service type automatically provisions a cloud load balancer? Answer: load balancer. Explanation: this type integrates with the underlying cloud provider API to create an external load balancer. Question 8. You are writing a network policy. You want to deny all traffic to a pod. How do you do that? Answer: create a policy that selects the pod but has an empty ingress rule. Explanation: if you select a pod but list no allowed sources, all traffic is blocked by default. Default deny. Question 9. What is target port in a service definition? Answer: it is the port the container is actually listening on. Explanation: the port is what the service exposes. The target port is where the service sends the traffic on the pod. Question 10. Can you have multiple ingress resources in one cluster? Answer: yes, absolutely. Explanation: you can have many ingress resources definition, usually handled by a single ingress controller. Question 11. You want to verify if your service is resolving correctly. What tool can you use inside a pod? Answer: NSLOOKUP less than service name greater than explanation. This queries the internal DNS of the cluster to see if the service name resolves to an IP address. Question 12. How do you expose a service on a specific node port, like 30,080? Answer: you specify node port 30,080 in the service YAML under ports. Explanation: if you don't specify it, Kubernetes picks a random one from the range. Question 13. Your ingress is not working. You check the resources and see address is empty. What is missing? Answer: an ingress controller. Explanation: the ingress resource is just a rule. You need a controller, like Nginx or Traefik, running to actually enforce the rule. Question 14. You want to restrict outgoing traffic from a pod. What is this called in a network policy? Answer: egress. Explanation: ingress is incoming traffic. Egress is outgoing traffic. Question 15. Can a service send traffic to pods in a different namespace? Answer: no, usually not directly via the selector. Explanation: services select pods in the same namespace. You can use an external name service to point to a DNS name in another namespace. Section 6, Security Contexts and Scheduling Details, Concept Overview. We made it to the last section. This is Section 6. We are going to talk about security contexts and advanced scheduling. This separates the beginners from the pros. First, security contexts. By default, containers might run as root user. This is risky. If a hacker breaks in, they have too much power. You can use run as user to force the container to run as a user with less power, like user ID 1000. You can also make the file system read-only, so no one can change your files. You define this in the YAML, either for the whole pod or just one container. Next, let's talk about scheduling. How does Kubernetes decide which node your pod goes to? Sometimes, you want to control this. 1. Node selector. This is the simple way. You label a node disk equals SSD. 2. Node affinity. This is the smarter version of node selector. 3. Taints and tolerations. This is for the node's protection. Imagine a node is reserved for special tasks. You put a taint on it. Finally, quotas. In a shared cluster, you don't want one team to use all the resources. A resource quota limits the total CPU and memory a namespace can use. If you try to create a pod that goes over the limit, Kubernetes will reject it. Mastering these concepts helps you build secure, efficient, and well-behaved applications. "15 Practice Questions", Section 6, Question 1. You want to force your container to run as user ID 1000. Which field do you add to the YAML? Answer: security context, run as user 1000. Explanation: this ensures the process inside the container does not run as root id 0. Question 2. You need to ensure a pod is scheduled on a node named node 01. What is the easiest way to do this for testing? Answer: use node name, node 01 in the pod spec. Explanation: node name bypasses the scheduler and places the pod directly on that node. Question 3. You have a node labeled GPU equals true. You want your pod to run only on nodes with this label. What do you use? Answer: node selector or node affinity, required during scheduling. Explanation: node selector, GPU, true, is the simplest method to enforce this. Question 4. A node has a taint, key equals value, no schedule. You want your pod to be able to run on this node. What do you need? Answer: you need a toleration in your pod spec that matches the taint. Explanation: the toleration acts as an exception pass, allowing the pod to schedule on the tainted node. Question 5. You want to prevent a container from writing to the root file system. It should be read-only. How do you set this? Answer: set read-only root file system, true in the security context. Explanation: this is a security best practice. If the app needs to write data, you should mount a volume. Question 6. You try to create a pod and get an error, forbidden, exceeded quota. What does this mean? Answer: The namespace has a resource quota and you have used up all the allowed resources. Explanation: you must either delete other pods or ask the administrator to increase the quota. Question 7. What is the difference between run as user and FS group? Answer: run as user sets the user ID for the process. FS group sets the group ID for ownership of volumes. Explanation: FS group is useful when you mount a volume and want to ensure your application can read, write to it. Question 8. You want to define a privilege setting for all containers in a pod at once. Where do you put the security context? Answer: at the pod level, under spec, not under containers. Explanation: pod-level security context applies settings like FS group and run as user to all containers, though container-level settings can override some of them. Question 9. You want to verify if a specific service account has permission to list pods. What command do you use? Answer: kubect l-auth can I list pods, as equals system, service account, less than namespace greater than, less than name greater than explanation. The auth can I command checks permissions for the current user or a specific impersonated user.